Hey, so let's look at some problems from the Module 3 Lesson 16 problem set. This one's all about the circumference of a circle, or sort of introducing us to pi since it's pi week. And so the main thing you got to know from this lesson is that pi is the ratio of the circumference of any circle to its diameter. And so this is often shortened rather than actually writing out the word circumference and diameter. You could say that pi is just equal to c divided by d. And then if we use our equation skills that we've been learning all throughout the rest of Module 3, we could multiply both sides of this equation by the diameter, or by d. Right? And what we get here is that this d on the bottom of the fraction here and this d that's now on the top, they cancel each other out. And we get d times pi equals c. In other words, if you take pi and multiply it by the diameter of any circle, you get its circumference. So that's pretty much what makes pi so cool. That's why we celebrate it. And now we're going to practice using it a little bit. So give an example. So I'm going to look at number 1. It just says find the circumference. That's all the way around the outside of the circle. So it says find the circumference. I think we're supposed to be looking at this circle that I just outlined the circumference of. Give an exact answer in terms of pi. So what they mean by that is they want you to use the actual pi symbol in your answer, and an exact answer has to have the pi symbol in it, because anything else that you try to represent pi with, like 3.14159, et cetera, or even this fraction 22/7 that's really close to pi, those are just approximations. They're not the exact number pi. We actually don't have any other way to write the exact number pi other than this pi symbol. Anything else you try to write is just going to be really close, but not the actual thing. So when they say give an exact answer in terms of pi, they mean, well, what's the diameter of this circle? If the radius is 14, then the diameter is twice that because it goes all the way across. And so that's 28. So 28 pi, that's the exact circumference of this circle. Remember, when you could kind of think as pi like a variable in this case because we're writing it almost like we write variables, but it's definitely not a variable because it doesn't change. It's always the same number. But just like when we want to write 28 times x, we just write 28x. We can do the same thing with pi. If we want to write 28 times pi, we could just write 28 pi. That's what I mean by thinking of it as a variable. It's not a variable in any other way. All right. So here, they want us to find the exact same circumference for part B, but this time we're going to approximate it using the fraction 22/7 instead of using the pi symbol. So what we're going to do is 28 again, because 28 is the diameter. So I'm going to write that as 28 over 1 times 22 over 7, because that's the approximation fraction they gave us for pi. And so I'm going to do a little trick here that I don't really actually usually do in class, but I know that when I multiply this 28 by this 22, I'll have a 7 on the bottom, but there will be a factor of 7 in whatever 28 times 22 is, because there's a factor of 7 in 28. 4 times 7 equals 28. And so what that means is I can sort of preemptively simplify this fraction a little bit. I can say that this 7 is going to go into this 28 4 times. So when I do some canceling and some simplification later, I know that I'll be able to get rid of this 7 and it'll become a 1. And up top, I will have a factor of 4 times this 22. And what we get is 88 over 1, or just 88. And I guess I should write centimeters, since this circle is in centimeters. So I could write centimeters over here too. All right, and then C. Use the pi button on your calculator and express your answer to the nearest hundredth. So they mean, if you don't have a pi button on your calculator, I don't know if ours do or not, I haven't really looked, you could just use 3.14. So in here they want you to do 28 times 3.14 instead. I should have grabbed a calculator before I started. Let me grab one real quick. Actually, I don't really need to do it. You can do it. You press 28 times 3.14. You should get something around 88. Okay, so pretty basic there. Let's jump to one that's a little bit different, since this one is very much the same. This one's pretty much the same too. You just got to realize that the side of this square is the same as the diameter across the circle, right? So they give you the diameter just in sort of a different way. Here, we want to find the perimeter of this semicircle, right? Semicircle means half circle. And the perimeter of it would be that line going straight across, which would be the diameter of the whole circle, this right here. And then this like half circumference here. And so we got to figure out what both those things are and then add them up. And here it says to explain in words how to determine the perimeter of half circle. Exactly what I just said. Find half the circumference of the circle, add the diameter, you're good. So B, using D to represent the diameter of a circle, write an algebraic equation that will result in the perimeter of a semicircle. So if we use P to represent the perimeter, that's what we're trying to figure out. Well, I know that pi times the diameter would get me a whole circumference, but I want half of that. So I could do 1/2 times pi times the diameter, and then I need to add this diameter that goes all the way across. So plus a diameter. And if you're really good at factoring, you could factor that D out and write it differently if you want to try that. So here you could use this formula to help you find an approximation of the perimeter of this semicircle using 3.14 for pi. And pretty much the same thing here, right? They want you to find the amount of material they need to go around this entire semicircle. So that's just the perimeter of it again. They give you the radius is 2.5, so that means the whole diameter right here is going to be 5. And so you can still use this same formula or the same equation to get your answer here. So part B, a little bit different. Kind of looks like baseball field a little bit. Oh no, I guess baseball field would be a diamond, not a triangle. If it went like this, then it would look more like a baseball field. But anyways, it says the diameter of a semicircular section is 10 meters, and the lengths of the sides of the two sides are 6 meters. Semicircular section. Oh, okay, so they want you to find. Oh, so this is still the question about the edging from question 5. So now they want you to find this here. Ignore, I'm going to use a different color because I already messed it up with purple. So what they want you to find is the total length of this. This plus this plus this. And so you're still going to use this diameter to find this half of a circumference here. And then you just got to add on these two angle sides here. Yeah, you know what? I'm going to let you do the rest without me.